We spent several days talking about different types of angles, and now we're going to talk about interior and exterior angles of triangles. The triangle angle sum theorem tells us that if we take the three angle measures in a triangle, that their sum will always be 180 degrees. So in example 1, if you add the three angles x, 53, and 78 together, that should equal 180. So to solve that, I'm going to add 53 and 78 together, which is 131. So x plus 131 equals 180. And then I'm going to subtract 131 from both sides. And 180 minus 131 is 49. So x is 49. That means that missing angle in example 1 would be 49 degrees. For example 2, if I add x to 22 to 90, remember that this angle right here, that little mark means it's 90 degrees. That should equal 180. So 22 plus 90 is 112. And then we're going to subtract 112 from both sides. So 180 minus 112 will give us 68 for x. Now on these first two examples, these really can be calculator driven, where you just take your calculator and do 180 minus 90 minus 22, and you don't necessarily have to show any work. But as we look at more examples, more work may be necessary. So for instance, in this example, because I don't have any numerical values of the angles, they're all expressions, I do want to set up an equation and solve. So you have two ways that you can set your equation up. Essentially, they're exactly the same thing. We can add x to 3x minus 11 to 6x minus 9 and set that equal to 180. Or instead of setting up that big, giant, long equation, if you just want to go straight to adding the angles, so look at your like terms, 3x, 6x, and x, that would give you a total of 10x. Oops. And then look at your constants. We have negative 11 and negative 9. That would give you a total of negative 20 equals 180. So if you want to jump to this step right here, that would be completely fine. So now we're going to add 20 to both sides, which is going to give me 10x equals 200. And then when we divide by 10, we're going to get x equals 20. For example 4, we do have just numerical values. However, we have two triangles within one picture. So remember that the triangle angle sum theorem says that the measures of the three angles within a triangle equal 180. So you need to make sure that you're thinking of this as two separate triangles. So there's the triangle on the left, and then there's the triangle on the right. We are looking for x, which is in the triangle on the left. The only problem is that in the triangle on the left, I have only one known angle and two unknown angles. And so because I have two unknown angles, I really can't do anything at this point with just the triangle on the left to find x. But if I look at the triangle on the right, I have two angles and a missing angle. I'm going to call that missing angle y. And we're going to take a second and we're going to first find y. So y plus 75 plus 67 equals 180. And then we're just going to do the same math that we've been doing. We're going to add 75 and 67 together to get 142. And then we're going to subtract 142. I'm not going to show subtracting 142 on the screen. I'm just trying to go straight to what y equals, and that would be y equals 38. So again, that's not what we're looking for. However, if I know that angle is 38, if you recall from the other angles we discussed earlier in the unit, that we have a pair of vertical angles, and vertical angles are always congruent. So that means that that angle over on the left side is also 30. And so now when we're looking at that triangle on the left, I know two of the angles and I'm missing just x. So I can do x plus 28 plus 38 equals 180 and solve it kind of like I did examples 1 and 2. So 28 and 38 is 66. And then we're going to subtract 66, and 180 minus 66 is 114. So x is going to equal 114. Sometimes you've got to think of it as a puzzle, and you've got to find other things before you can get to your desired angle. So just as a recap, the triangle angle sum theorem, also known as just the triangle sum theorem, says that the three angles in a triangle add to equal 180 degrees. The other theorem we're going to talk about is the exterior angle theorem, and it is derived from the linear pair property and also the triangle sum theorem. If you put those together, you'll actually get this. And what it says is that the measure of an exterior angle, so in that picture, the exterior angle is angle 1, is equal to the sum of the two remote interior angles. The remote interior angles are A and B. Those are the angles that do not touch the exterior angle. They're not adjacent to the exterior angle. So example 5 is a very straightforward problem. So in example 5, the exterior angle is x, and it should equal the sum, which means you're going to add, of the remote interior angles, and those are the angles that are not adjacent to the exterior angle, so that would be 73 and 62. So if you just add those together, that would give you 135, so that exterior angle would be 135. Now, I've had other people say, well, can't I find, and I'm just going to, find that other interior angle inside the triangle. And you definitely can take that approach for this particular problem because it's all numerical values for your angles and you don't have any expressions. So you could do, add 62 and 73 together, which gives you 135. And then, do 180 minus 135 to get you that angle. That would be 45. And then x and y are a linear pair, so then you could do 180 minus 45, and that would get you back to 135. So it can be done by using the triangle sum theorem to find y, and then using linear pair property to find x, but you're kind of doing double the work. So if you know the exterior angle theorem, it's just going to be a quicker approach. And again, that only works in this particular problem because your known angles are numerical and they're not expressions. So you'll see, not in this example, but the next example, that would not work. So again, exterior angle theorem says take the exterior angle, which is x, and it should equal the sum of the remote interior angles. Those are the ones not adjacent to x. So that would be 31 plus 90. And 31 plus 90 is 121. So that exterior angle will be 121 degrees. X is 121. So in example 7, all three angles are numerical expressions, so we are really going to need to be able to use that exterior angle theorem. So our exterior angle is 4x plus 29. And that should equal our two remote interior angles, so that's 2x and 5x. Oops, I'm sorry, 3x. I was doing the math ahead of time. So 2x and 3x is 5x, so that gives us 4x plus 29 equals 5x. I'm going to move my 4x to the right side just to get my variable isolated since the constant of 29 is already isolated. That gives me 29 equals x, or x equals 29. And you can always, especially in ones like this, go back and substitute in the value that you get for x into the expressions and make sure that they make sense. If I do 4 times 29 and then add 29 to that, that gives me 118. Let me make sure that's right. I don't think that's right. gives me 145. If I do 2 times 29, that gives me 58. And if I do 3 times 29, that gives me 87. And so we can check and make sure that 50 plus 87 is 145, and it is. So that's a good self-check for this particular problem. The last example is very similar to example 7. Our exterior angle is 7x minus 15. That should equal the sum of our remote interior angles. So that's x plus 28 and 4x minus 3. You can go ahead and combine like terms if you want to before writing it out. We've got x and 4x, which is 5x, and 28 minus 3 is 25. I'm going to move my 5x to the left side and my 15 to the right side. That is going to give me 2x equals 40. Divide everything by 2, and x equals 20. And again, like example 7, if you want to make sure that you've done this right, you can plug it back in. Do 7 times 20, which is 140, and 140 minus 15 is 125. 125. And then if I put it in for the top angle, 20 plus 28 is going to be 48. And if I do 4 times 20, that's 80, and 80 minus 3 is 77. And then just double check that 48 plus 77 is 125, and it is, so we are good. So to sum up the exterior angle theorem, the exterior or outside angle in a triangle is equal to the sum of the 2 remote interior angles. Those are the angles that are not adjacent to that exterior angle.